What's going on, you guys? Mr. Allen here, about to solve some rational inequalities in this video, and these all start the same way. I got to factor first to find my critical values, okay? So in the numerator, what multiplies to 5 and adds to 6? That's going to be 5 and 1. So x plus 5, x plus 1. Down here, we got a difference of two squares, x minus 1, x plus 1. We'll do the trick, is less than or equal to 0. Okay, so I've got this thing in factored form. And now what I need to do is find all my critical values, as I like to call them. All right, I'm going to place them on a number line, but I'll list them out first. So here, I'm going to have a whole, right? So a whole x equals a negative 1, whole at x equals negative 1. So we'll say at, sorry, that's really jumbled up. And then I've got myself, let's see here, a vertical asymptote when x equals positive 1. And then up here, what's that x plus 5 to me in the numerator? That's an x-intercept, okay, or a 0. X-intercept, that's going to be for the negative 5, all right? So negative 5, comma, 0. Cool. So those are all my important values, my critical values here that I'm going to throw on my number line and test, okay? So you could graph this, but this is kind of a pain, okay? This is why usually with polynomials, we'll show you a graph, but you can also, we'll also show you the number line here because the number line makes it a little easier when we come to these problems, okay? Because graphing all rational is kind of a pain. Polynomial, not so much. Rational, it's a lot of stuff. Okay, so when I put these numbers down, I make sure to state what they are as well. So I got negative 5, that's a 0, or x-intercept. Then I've got negative 1, that's a whole, or removable discontinuity. Removable discontinuity. And then I got 1, that's a vertical asymptote. Because here's the thing, is these are going to, my answer is going to be different based on what each one of these are. Okay, how I write my final answer. Am I including these points? Am I not including these points? All right, with polynomials, it's all kind of a one thing here. That's a 1 right there. But with rationals, it's a little different. Okay, so test values. I really don't need to worry about this right here because it's gone. It's going to be the same thing no matter what. So whether they're both negative or both positive, it doesn't affect the overall sign. So nice and easy just dealing with these two here. So if I pick negative 6, right, I'm going to get a negative divided by a negative. That's two negatives. That is positive overall. For my next one, I'm going to have, let's see here, how about negative 2? If I plug that in, I got positive over negative. So positive, negative, that gives me negative overall. Then between these, I got 0. So I got 5 over negative 1. That's going to be negative. Okay, so hold up. So we got negative and negative, sorry, positive and negative. It's negative overall. And then after my vertical asymptote, we've got, let's test 2. I've got positive divided by positive. So positive, positive makes it positive overall. All right. So right off the bat, something different if you're used to doing the polynomials and this is your first time doing these. I got 2 negatives in a row. Well, that's just a whole, right? It's just a whole. So that's not an x-intercept. That's not where it's going to be changing sign, right? It's just a value that's removed from the function, all right, or from the graph. So let's write our final answer here. We want to know when is it less than or equal to 0? Well, that's going to be when it's negative, right? I'm figuring out when it's positive or negative because that'll tell me when it's larger than 0 or less than 0. 0 is the cutoff there. So I'm between these two here, but not including this, okay? So at negative 5, it's equal to 0. So I want to include negative 5. At negative 1, that's a whole. We can't include that value. So that's going to be a parenthesis, no matter what, okay? Whether it was equal to or not equal to, it's going to be a parenthesis around a whole. All right, and then we're going to pick right back up with that negative 1, and then we're going to positive 1. Now, am I including that value or am I not including that value? It's a vertical asymptote, which means I'm going to get infinitely closer to it, but never get to it. I am not including it. That is my final answer there. Nice. Excellent. If you wanted to write this with inequalities, you can. I don't prefer it, but you can do it if your teacher wants you to. It would be something like this. Boom. And then I would have between negative 1 and positive 1. No equal to's on those. I don't like that as much. I feel like that's much more clear, which is why I use that one, and I would have my students use that one. I do use, set notation from time to time. It just depends on the problem. All right? Last one here, dogs. Let's factor that numerator and denominator, just like we did the last one. We got x, what, minus 6, x plus 2. That multiplies to negative 12 and adds to negative 4. Down here, ooh, weird. 2 terms? We never see these. GCF. Don't forget about GCF, man. GCF comes in clutch here. Okay, so I don't have any holes here. No holes. Well, what do we have here? We got x-intercepts or zeros. I'll call them zeros on this one because I did it down here. I feel like that's better. I don't know. All right, so that you're going to have a 0 when we have x equals 6 and -2. Vertical asymptote. We got x equals 0, and we've got x equals 3. All right. So that's what everything does here, right? We're just talking about like what it is, what kind of feature it is on the graph. Vertical asymptote didn't cancel, so x equals 0. This guy here, x equals 3. And then in my numerator, those are my zeros because whatever, if my numerator is 0, 0 divided by anything else is going to be 0, okay? So those are x-intercepts or zeros. All right, I've said 0 enough. Let's throw this on a number line here. So in numerical order, -2, that's a 0. We've got 0, vertical asymptote. We've got 3, it's a vertical asymptote. And we've got 6, which is a 0. Cool. Awesome. Now, time for the sign test, okay? Unfortunately here, nothing canceled, so we got to check all of them, okay? So if I plug in -3, I'm going to get a negative, got a negative, negative, negative. 4 negatives is a positive overall. Beautiful. All right. Now how about -1? First one's going to be negative. That's going to be positive, negative, and what is that? Negative then, right? If I plug in what did I say? -1? Yeah, cool. So 3 negatives, that's negative overall. Then let's do +1. So that's going to be negative. That's going to be positive, positive, negative. 2 negatives, positive overall. Then I'll do 4. That's going to be negative. That's going to be positive, positive, and this will be positive. So 1 negative, 3 positives is negative overall. And then let's see here. 7 would be positive, positive. All of them would be positive. So we get positive overall. All right. Cool. Awesome. Fantastic. Now, we just got to write our answer. That's a whole lot of positives and negatives there, guys. Whole bunch of positives and negatives. I just want to double check here. When I plugged in 1, negative, positive, positive, negative. Cool. And then 4 was negative, positive, positive, positive. Okay, cool. Awesome. I like to double check some of these because it's easy to make a mistake. All right. When is it greater than 0? Well, from -infinity to -2, and we're not going to include it here because it's just greater than. Had it been greater than or equal to, we would have included it because it's a 0. All right? Asymptotes, no. All right, so then where else is it positive? We got between 0 and 3. And then I've got from 6 to positive infinity. Very nice. 3 intervals. All right, so again, if let's do this real quick. I think this is better than doing the inequality notation. But let's just say it was greater than or equal to. Actually, let me do this in green. So if it were greater than or equal to 0. Okay, this is the little what if right now. This would be -infinity to -2, including that -2. 0 and 3 would still not be included as they are vertical asymptotes. And then my 0 here, I'm going to include that 6 and then not the infinity. Okay, so that's the difference if it were greater than or equal to versus just greater than. I know there's some confusion there a handful of times. So hopefully that helps you guys, that you enjoy the video and you thoroughly enjoy these rational inequalities because they are kind of fun once you get to doing them, testing things out. You feel like you're smart doing this stuff and it's cool. All right, so practice makes perfect. Have a wonderful day and good luck on your tests, your finals, whatever it may be that you're studying for, and stay dope.